Hi class, Professor Smith here. So excited to create a video on estimating a limit numerically, problem type 1. In this example, we're asked to complete the parts below to determine the apparent value of the following limit. And we have the limit as x approaches 0 of x plus 1 raised to the third power minus 1 all over x. And since we're asked to fill in the blanks and approximate this example numerically, you would think, well, why don't we just go ahead and plug in the value of x equal to 0 into our expression? And when we do that, we get 0 plus 1, which is 1. And then when we raise it to the third power, it's 1. So in the numerator, we have 1 minus 1, which is 0. And then when we substitute in x equal to 0 in the denominator, we also have 0. And so we have 0 divided by 0, and that is indeterminate. In other words, that expression, 0 over 0, could have a whole host of possibilities, and we'll see one of them in this example. So instead what we do is we say, well, as x approaches 0, we're going to find x values that are close to 0. So you can see in this table, we start with negative 1, because that is close to 0, and then we take zero point 0.5, taking it in half, and we get 0.05. And then we take 0.05, and excuse me, both of those are negative, negative 0.5 and negative 0.05. And all of those values are getting closer and closer to 0. And then we have negative 0.001. And then what they've done is they filled in, well, what does this expression equal when we substitute in those x values? So when we substitute in x equal to negative 1, we get 1. Negative 0.5, we get 1.75. Negative 0.05, we get 2.8525. Negative 0.0001, we get 2.9970. And so you can see as x is getting closer and closer to 0, we call that approaching from the left, from the values to the left of 0, which are negative. We see that our functional values, x plus 1, raised to the third power minus 1 all over x, we see that that expression looks like it's getting close to, here we go from 2.8525, 2.9970, looks like we're getting close to 3. So then we say, well, let's go ahead and approach 0 or find values that are close to 0 from the right. And so here we're going to plug in the values because they don't give it to us for 0.01 nor 0.05. And what we're going to do is we're going to use the ALEKS calculator to find that computation. So over to the right, you see the icon that says calculator. I clicked on it, it opens it up. And then what I'm going to do is I'm going to substitute in the expression for the function that we're finding the limit of. And so I'm going to plug in x plus 1 quantity cubed minus 1 all over x. However, I don't have an x creature on the graphing calculator, but what I'll do instead is I'll select the division bar that's on the graphing calculator. It's off the screen, so I'll go ahead and make this smaller so you can see it, and then I'll reduce it back. So I'm going to select the division bar, and that's going to create that fraction. And then what I'm going to do is I'm going to put in parentheses the first value, which I think was 0.05, 0.05, and then I'm going to put in plus 1, close parentheses, and then I'm going to raise it to the third power. And I can do that by selecting the X to the Y button, or you can do Shift 6, that's the caret button, Shift 6, and I'll raise it to the third power. And then I'll go ahead and subtract 1. Oops, I'm subtracting 1 in the wrong place. I thought I tabbed down, but I didn't. All right, minus 1. All right, and then I'm going to substitute in that x value again of 0.05 in the denominator. So 0.05. And then I'm going to hit equals on the calculator, or I'm on my keyboard on my computer, and I'll hit return. And that's the same as hitting equals. And so I do that, and I get 3.1525. So I'm going to substitute that value in. So I'm going to highlight it. And then in order to copy it, and I did that by dragging my mouse over all those digits, and to copy it, I'm going to select Command C, because I'm on a Mac, or you could hit Control C, CTRL-C on a PC. So Command C on a Mac. And then I will go ahead and paste in that value. So we move the calculator out of the way, and I'll paste in that value. I noticed that the other values when I look on the table, they're to 4 decimal places, so I wrote it to 4 decimal places again. Now, this is the cool thing about the Alex calculator. Try not to get excited. You can select undo, and when you select undo, now I don't have to type in that whole expression all over again. I'm just going to now replace it with my new x value. So I already plugged in 0.05. Now I'm going to plug in 0.001. And then I'm going to do the same thing in the denominator. So I replace the 0.05 in the numerator with 0.001, and I'm going to do the same thing in the denominator. So I'll get rid of the 5 and add 0.01. So now I have the expression now replaced with 0.001. I'll hit return, or you can hit equals on the keyboard. And when I do that, I get 3.0030. So I'm going to copy the the 4 decimal places and the digit to the right of the decimal. So I'll copy that, Command C, and then to paste it, I'm going to hit Command V as in Victor. And there I have my 4 decimal places. And as I suspect, as the x values get smaller and smaller and smaller, closer to 0, the limit gets closer and closer to, looks like I would say 3. So we'll go ahead and plug in our answer here of 3. And then we'll go ahead and check our work just to see if we indeed got it correct. And wahoo, Alex says correct. So I hope this video on estimating a limit numerically, problem type 1, has been helpful for you.